Are you tired of getting cock-blocked by ChatGPT just when you're about to get saucy with your AI waifu? Hi, Billy Mays here for Local Models. With Local Models, your chatbot can do anything from boring vanilla stories to the most unhinged degenerate shit imaginable. Even if you have a toaster, you can find a model that runs for you absolutely free. Try a Local Model today, and I guarantee you'll run out of VRAM or your money back.
Hello, in today's video we are going to be talking about local models and Sillytavern. So if you've never used a local model before, or if you've just gotten started and don't know what to do next, this video's for you. Let's get started by discussing the software you'll need to run things locally. In case you didn't know, Sillytavern is not actually capable of running local models by itself. However, it has easy integration with several third-party solutions. We'll be looking at two of these today. Sillytavern recommends, and I agree with these recommendations, either Oobabooga Text Generation WebUI or KoboldCpp. Now, before we discuss the particulars, let's discuss what Sillytavern is actually doing under the hood. Sillytavern works by managing the context, history, and world-building elements of your roleplay session, and when it needs more text, it reaches out to an LLM server somewhere. This could be someone else's service like ChatGPT, or it could be a server running locally on your computer. Actually, it doesn't have to be the same machine that is running Sillytavern. It could be another one on the same network. And in fact, this is how I'm using it myself. I've got my main machine that is running Sillytavern, and a remote machine that is running the LLM server. It's fairly easy to set this up. So let's take a look at our first solution, which is Oobabooga Text Generation WebUI. If you're non-technical, I do recommend trying this one first. All you have to do is run the startup script for your system, follow the setup wizard, and then you'll be up and running in a matter of minutes. Just remember that there's a file called commandflags.txt, and you'll need to add the --API flag in order to connect with Sillytavern. That's all you'll need if you're running locally, but if you're using another machine like I am, you'll need the --listen as well. All that does is open up the server so that you can connect to it from the outside. If everything went well, you'll be able to open up the server on an interface that looks like this. There will be a printout on command line that tells you which address and port to connect to in your browser. Go on over to the Model tab, and this is where we'll be managing our models. Once you've found a model you like, simply enter it in on the right side in the Download section. Oobabooga will automatically manage downloading the model, and when it's complete, it'll show up in your drop-down menu at the top. We'll discuss later which models to use, but for now, I've got one pre-downloaded and ready to go. Simply find the model you want and load it. And once it's loaded, we're going to want to test it out first before going to Sillytavern. Let's go on over here to one of the other tabs and ask it a basic question like, what's 2 plus 2? It may take a second to get going at first, but once it's going, you should see text get output. And of course, if it's not outputting gibberish or throwing errors, that means it worked. So now that we've established that everything works, let's go on over to Sillytavern and connect. The connection indicator should turn green, and the model you're using should be shown below as confirmation. And the only thing left to do now is use it. And we can see that everything is all well and good. And if this works for you, that's all there is to it. However, for me, there's a catch. You see, Oobabooga has never quite worked right. It sort of works right for some models, but for GGUF models specifically, it's given me a lot of headaches. And that's why I'm going to go over this alternative, which is KoboldCpp. And since I have an AMD card, I'm using the ROCm fork. Now, if you're on Windows, congratulations. All you have to do is go to the release section on GitHub and download the appropriate executable. For NVIDIA users, you'll want the original Lost Ruins KoboldCpp, and for AMD users, you'll want the Yellow Rose CX ROCm fork. Now, for Linux users, you'll have to compile it yourself, but that's pretty easy. All you have to do is use make, follow the instructions on the GitHub, and if you have Arch Linux, there is already an AUR package ready to go. By the way, if you're compiling from source, I do not recommend using the main branch. Go to the tags and look at the latest release. The main branch tends to be a bit unstable. Just go to the latest release and do a git checkout of that specific commit. At any rate, you'll be running KoboldCpp on the command line. You'll have to specify a couple command line arguments, including the model name and the number of layers to offload to the GPU. I haven't covered layers yet, but we'll get there shortly. Once it's running, and assuming it hasn't crashed, you connect to it in the same way in Sillytavern. All you have to do is specify KoboldCpp API. Once it's all connected, you're ready to go. You'll see a slight delay at first, but don't worry, that's just the model warming up. And when it starts writing, we can see this counter on the command line that corresponds to the output being streamed to Sillytavern. And there you have it. 2 different methods of hosting your model, and if neither of these float your boat, there are other options like VLLM or any OpenAPI-compatible server. Now that we've got that covered, let's go over the models themselves. The first question we should be asking is what models can we actually run? You're going to want to select a model size range that's appropriate for your hardware. Model sizes are usually described in terms of the number of parameters that they have. You'll see this described as something like 8B, 70B, 120B, and these are the number of billions of parameters that comprise the model. Now, you might be inclined at first to believe that the model size is reflective of the amount of data that it was trained on. This is not quite correct. Models of many different sizes can be trained on the same dataset. The number of parameters is more like that model's working memory of that dataset. You can think of it more as the brain size of that model, where larger models are generally quote-unquote smarter and can process a dataset more effectively. But of course the downside is that larger models have higher system requirements. We can break down these model sizes into a few different categories according to the hardware required to run them. The smallest is from about 1.5 to 3.5 billion parameters. These can run on very limited devices, like a Raspberry Pi with just 4 GB of RAM and no graphics card at all. The next are models in the 7 to 14 billion parameter range. Realistically, this is the smallest category that is viable for roleplay, in my opinion. And these models can run comfortably on a laptop or entirely on a mid-range GPU. Next are models in the 20 to 40 billion parameter range. These models can run on something like a mid-range gaming PC. And in fact, models in this size range are what I personally like to run on my machine that has 32 GB of RAM and a graphics card with 12 GB of VRAM. The next size up are models around 70 billion parameters. These models are best run on high-end gaming PCs. You're going to want at least 16 GB of VRAM and probably around 64 GB of RAM. The next size up from this are models that are around 120 billion parameters. These are models best run on very high-end machines. You might be able to run it on a high-end gaming machine, but even so it could run very slowly. Models larger than this start to approach a size that is unrealistic for consumer hardware. There are very large models out there, such as DeepSeek R1, that are over 600 billion parameters. And even if you can get these models to run on your consumer-grade machine, it will be very, very slow. Fortunately, for our purposes, which is running roleplay scenarios in Sillytavern, most roleplay models are in the range from 7 billion to 70 billion parameters. So we'll be focusing on models that are within this size bracket. Now let's take a look at the speed of these models. I have here loaded an 8 billion parameter model onto my GPU. Let's not worry about the exact model name right now. It's this one if you're curious. But right now, let's pay attention to how fast the model outputs text. As you can see, it's blazingly fast. And over here in the corner, I have displayed my VRAM usage. On my 12GB card, this is nothing. If you have a laptop with, say, integrated graphics, it's going to be slower than this, but it will probably still output things faster than you can type. That's why role-play models of this size category are so common. They're super accessible, and anybody can run them. Now let's go up to the next size category and take a look at a 22 billion parameter model. I can run roughly 3/4 of this model on my GPU, but the rest of it has to run on the slower CPU. We can see that the output is still acceptably fast, and that's because most of it is still running on the very fast GPU. Contrast that with this 70 billion parameter model, which is really taxing the limits of my system. I can only run 1/3 of this model on my GPU, and in total it takes up all of my RAM and VRAM. As you can see, its text output is excruciatingly slow. Now, technically I could run models larger than this, but it's not worth it. I've found the upper practical limit for my system. Next, let's discuss the different types of models that are out there. We are looking for models that are good at roleplay, and not all models are suitable for this purpose. One model that you're likely to encounter is one that's often called pre-trained. Think of these as wild, untamed models that are trained on massive amounts of data. Sometimes these work pretty well for roleplay because some of those datasets include literature and roleplay scenarios. But usually they're not specifically designed for role-playing, and usually they're not designed for anything in particular. If you want to get a feeling for how large language models work, generally speaking, it's a good idea to start with pre-trained ones. Let's take Gemma from Google, for example. I've loaded up the 9 billion parameter pre-trained model. And just to illustrate a point, we're going to interact with it in the most raw form that we can. That is, the form of text completion. I've primed it with the text, "The Quick Brown Fox," and it's going to output what comes next, and it will keep outputting this until it thinks it's done or I've asked it to stop. There's no real rhyme or reason why it output what it did, and if I try again, it'll output something different. This time, it's decided to write in another language. There's 2 reasons for this. One, it's just kind of a wild, untrained model. You never know what it's going to output. And 2, we haven't given it a lot to go on, so it doesn't know, really, what should come next. All I've said is "the quick brown fox," and it just has to go from there. This is called context, and it's a very important concept for understanding how large language models work. Context is quite simply the text that you've provided to it before you ask it to start generating more. There's a limit to the amount of context that you can provide it, and more context means more memory usage. By the way, if you're running out of memory while trying to load a model, you can try reducing the maximum context length. This means that less history will be fed into it, but at least you'll be able to run models that you otherwise couldn't. Let's take a quick digression and talk about Sillytavern's context management. As you continue your scenario, everything that came before is fed into the large language model as context, and eventually your history will grow to be too large to fit into the context window. This means that the character played by the AI will forget everything that came before a certain point. To manage this, Sillytavern tries to summarize everything that happens beyond the context window. This is the summary module, and what it does is basically ask the LLM behind the scenes to summarize the chat, and this summary is fed in as additional context at the start of the chat. The idea being that we can expand the chat history beyond its natural context limit. Now, of course, this summary is only as good as the LLM can make, and inaccurate summaries are more detrimental than helpful. So remember, when you're running through a scenario, keep your eye on the history. And if the summary is not up to snuff, you can always pause it and manually write your own. Anyway, let's get back to the main topic. We were discussing context. Instead of giving it a few words, like the quick brown fox, let's start with something like a Wikipedia article. We'll just copy-paste the text here and see what it comes up with next. As you can see, it's no longer wildly unpredictable. It's adapted to what came before, and it's writing in that style. As we keep asking it to do this again, it is highly likely to produce something very similar. And this is not unique to how pre-trained models work. This is the very basis for how large language models operate. So with that in mind, let's move on to the next type of model, which is called the Instruct model. For these models, we take the wild pre-trained models and try to make a chatbot out of it. So they are further trained on a new template, that of a chatbot interacting with a user. So we're basically banging the model into shape, making it fit a more familiar chat interface rather than this raw text input. This is also the stage at which the model starts to become censored. If you ask it a question like, how do I build a bomb? It could be trained to reject that question on the grounds that it's dangerous. This is called supervised fine-tuning. This is in general an important step because this is where the model learns how to behave more like a chatbot rather than something that outputs bulk text. But this is also where the model learns where some responses are good and some responses are bad, and where it learns how to be quote-unquote ethical. But what if we like a model's capability, but we don't like how censored it is? Is there anything we can do about it? Into the concept of obliteration. That's obliteration with an A. You see, people have figured out how to identify where the model censors itself. It turns out that uncensored answers are still there in the recesses of its mind. It just has to be unlocked. So the process of obliteration is the process of uncensoring a model. And obliterated models are very popular for roleplay for obvious reasons. So next time you're looking at model names and you're wondering what terms like instruct or obliterated mean, now you know. Now, one problem with instruction training is that it's not standardized, so each model family has a different format. And Sillytavern supports these different formats. It's called the instruction template under advanced formatting. And while configuring this is not strictly necessary, you'll have better results if you're using a specific instruct model. For example, here I'm using Gemma 2 Instruct, and if we go over to the Instruct template, we can see that we have an option for it. When enabled, Sillytavern will insert these Instruct sequences into the conversation. Let's test that out and look at the command line. We'll wait for the message to complete and see if we can identify the Instruct sequences. Ah yes, we can see that my message has been wrapped in start of turn, end of turn. Like I said, this is not strictly necessary to set up, but it can improve your results. It can help to differentiate between the user input and the model output, so it can help with things like keeping the model in character and preventing the model from speaking out of turn. The next thing we have to cover is model merging, or mixing as it's sometimes called. This one's fairly straightforward, especially if you're already familiar with other technologies like Stable Diffusion. Let's say you like Model A because it's very good at staying in character, and you like Model B because it's very good at writing prose. You can merge the two together and get some of the properties of both. Many popular models used today for roleplay are merges of 2, 3, or maybe even 4 models. Much like Stable Diffusion, if you're browsing random models by random people, chances are that most of them are going to be merges of other models rather than models trained from scratch themselves. Just keep that in mind next time you're browsing Hugging Face and you encounter a bunch of models that have 3 or 4 different names thrown in. So now that you know the basics, you're ready to find a model. But where do you begin? Instead of giving you specific recommendations that'll be outdated within a month, I'm going to give you a few resources. First is my personal favorite, the UGI Leaderboard. UGI stands for Uncensored General Intelligence, and this leaderboard has rankings for how uncensored models are. Now, it's important to keep in mind that this ranks all kinds of LLMs, not just one specific to roleplay, so this is more of a starting point for finding new models rather than a definitive list. It has a handy model size filter so that you can search for only the models that you're interested in within a certain bracket. In fact, this is how I found my current favorite model, Cydonia Magnum 22B. In fact, let's look at this one as just an example. We can see here that this is in fact a merge of two different models, Cydonia and Magnum. And if we look at Cydonia, we can see right away that this is a storytelling model themed on adventure. You can usually tell by the model card if it's a role-play model or not. Let's go back to the UGI Leaderboard for a bit. I'm going to open up the filter to include 7DB models and then sort by test date. And we can see that this is updated on almost a daily basis. So this is a really good way to keep up with the most recent stuff. And even if you see a model that doesn't score high on the benchmark, benchmarks aren't everything. They're just another tool that helps you know what to expect. Next, let's take a look at the Stick to Your Role leaderboard. This one measures how well a model stays in character and how well a model stays true to character. You may notice that some of the top scorers are Instruct Models. So now you know what that means and what you need to configure in Sillytavern to get it to work correctly. This leaderboard's not updated quite as often as the UGI one, but it's still useful. Just keep in mind these rankings don't necessarily take into account how censored the model is. So if you find a model that ranks highly on both leaderboards, now you have a winner. Finally, we'll take a look at the Openrouter LLM Rankings. There's an entire category for roleplay models, so very useful. Now, this list doesn't discriminate between open and proprietary models, so you're going to have to filter that out for yourself, and the site is oriented more towards using their services rather than self-hosting. But make no mistake, you can host these models yourself if you just look them up. For example, if we just take a look at Mythomax 13B, copy its name and search for it, we find it quite easily on Hugging Face. So now let's take a look at Quantizations, the final thing you'll need to know about before you download a model. Quantizations are an important part of running local models because usually you don't have the hardware to run the original full precision model yourself. Think of it as a type of lossy compression where you lose some details but make it much, much smaller. The most popular type of quantization today is GGUF. This format allows you to split the model between the CPU and the GPU, whereas previous formats would only allow you to run on one or the other. It does this by splitting the model's layers, allowing you to select how many layers you want to run on the GPU. Each model and each quantization has a different number of layers, so it's a case-by-case basis on how many layers you can offload. GGUF models come in a variety of sizes. The smaller ones are of lower quality, so you're going to want to run the biggest one that you can. But this also allows smaller machines to run bigger models. For instance, even though I'm more comfortable running models in the 20 to 30 billion parameter range, I can run a 70 billion parameter model, albeit at a lower quality. Let's take a look at a real-life example. Most of the time when you search for models, you'll come across the model's main page. These are the full-size models. They are used for training and mixing, and you typically don't want to run these. However, if we look at the right side of the page, we can see a link to Quantizations. These are the ones that you actually want to run. We have a few options, but let's go with Bartowski because his pages are usually well documented. We have a lot of options here, from 75 gigabytes to 16. The one on top is the highest quality, and you should run it if you can. But personally, my machine is only capable of running the 32 gigabyte version. Something to keep in mind is that even if you can run the highest quality one, if it's running a little bit too slow for you, you can always do a quality-speed trade-off and go a notch or two lower. But at any rate, I don't really recommend biting off more than you can chew. There are plenty of models in every size category, and while it can be tempting to want to run the biggest and best models out there, it's just no good to overtax your system. So let's bring everything back to Sillytavern. You have all the knowledge you need to find and run the model, and now we're going to evaluate it. Now, in my case, I've already evaluated this model. I'm just showing it to you as a good example. I'm using Cydonia Magnum 22B, as I discussed earlier. And the first thing we want to ask is, do we need an Instruct template? And in this case, no, it works just fine without it. And the second question we need to ask is, do we need to change its configuration? Usually you don't really have to change anything aside from the context size. In my case, I'm going with 4096. I could go with twice that much if I wanted to, but it also takes up more memory, and I don't really want to do that. A good starting point is always the default scenario. You don't have to worry about world building or character building or anything. You can just jump right into it. And what I usually do is ask a basic question. Where am I? I'm doing this to see if the model has ingested the world and character background correctly. It's good if we can see it weave in the backstory, and we can also get a good idea of how well it writes prose. And we can re-roll this several times just to see what kind of variety we have. Of course, we could continue the conversation, but I'd rather drop into the middle of an established one. This one's a group chat with a very long history, so I like seeing if it can make good summaries. Now, if your model's bad at summarizing, that's not necessarily a deal-breaker. And you have a couple options. First, you can try to change the chat summary template. This is the instruction given to the model to get it to summarize the conversation. But in my experience, trying to ask it 5 different ways doesn't really help much. It's either good at making summaries or it's not. And your other option is to disable it. Honestly, I don't think summary is that much of a value add, so don't feel too bad if you can't use it. And of course the other reason I've dropped it into an existing conversation is that I want to see how good it is at resuming an established chat. And I especially want to see how good it is at doing multiple characters. Each of these characters has a unique personality and way of speaking, so I want to see how good it is at maintaining these multiple personas. But aside from these initial tests, I just use it normally. There's not really a secret to evaluating a model. You just use it normally, and if you like it, you keep it. And part of the fun of local models is that you can always try something new. But that's about all I've got for today. We're already past 25 minutes, and that's kind of nuts for me. And sorry for some of the vocal glitches today. I'm trying something new out, and it's not really working very well. Maybe I shouldn't have experimented on a large 25-minute video, but it's too late for that. Anyway, I'd like to end on this final note. In the world of local models, size isn't everything. You might be tempted to try the biggest models that score the highest on all the benchmarks. But a lot of those models have other focuses like programming and math. And a lot of good role-play models are actually very small and accessible. I could be ambitious and run some 70 billion parameter beast, but some of the most fun role-play experiences I've ever had are on humble 7 billion parameter models. So if I could leave you with just one word of advice, it would be this. Don't worry about what's the biggest. Don't worry about what's the best. Just try stuff and have fun. Anyway, why are you still here? You've got models to run. Bye now.